Hey, biochemistry students. These are the ideas for section 3 subatomic particles and isotopes. And when we look at the slideshow here for section 3, some things stand out. Um, one thing that's important to know is that electrons have a mass significantly less than protons. Now, protons' mass and neutrons' mass are similar in size. And so just keep in mind that when they count the overall mass of an element, they usually don't count the electron because it's so significantly small. So there's that. It takes a lot of electrons to equal the mass of a proton. This is a slide that shows this idea. However, it shows also that neutrons are slightly larger than protons. Okay, so we'll move on. In terms of a model of an atom, if a fly were to be the nucleus in the middle of a stadium, that would be the size comparison of an atom size. So really, when we look at the perspective of the size, the nucleus is minimal in size. Although it has the most mass, it's minimal in size. Electrons just have a lot of space to move around the nucleus. Here's a nice perspective builder. This would be for a hydrogen atom if the hydrogen nucleus, the proton of a hydrogen atom was this size that you see here in the picture, then you would have to go out a half mile each way. Is where the electrons would stretch out to. The one electron would stretch to. Okay, you can see there's a lot of empty space. Now, this brings us to really the main focus of section 3, and that is the isotope idea. Now, isotopes mean that the element is the same. It's just that there is an addition of neutrons. So, for example, this is depicting hydrogen, and it shows additional neutrons added to and giving the hydrogen a different mass. So you can have the same element, but when you add neutrons, then the mass changes. Still the same element, though. Okay, so one other thing to keep in mind is that for purposes of what we're doing for now, the number of electrons will always be considered the same as the number of protons, so that atoms are thought to be neutral. Okay, let's keep moving here. So what is the atomic number? It is the number of protons. And when you look at the periodic table, you're going to see some numbers. You'll see a symbol for the element, and then the upper number is the number of protons, or the atomic number. Then there's the mass number. Now, the mass numbers tend to be odd numbers, and we'll do more on that later. They are actually the average atomic mass on the periodic table. But for purposes of isotopes, it's very easy. We'll use whole numbers. So you can see here, for example, there's a couple ways to show the isotope notation for hydrogen's isotopes. Let's see here. Moving here. All right, so we'll just look through these. I'm gonna have you guys doing some practicing with this so that you really master the concept of the isotope. So that's the main focus in section 3. When you do your notes, just make sure you pay attention to that idea. The proton determines it's the atomic number, and it determines what element in question. And then the number of neutrons can be added to that, which changes the mass. Okay, that's it for now, and we'll talk to you later.